Hi everyone, this is Mrs. Blake, and today we're going to talk about stoichiometry. Stoichiometry is a big fancy word that sometimes is intimidating, but the concept itself really isn't so bad. Stoichiometry in chemistry commonly is referred to as stoic, and the best way to take a look at stoichiometry is to take a look at an actual example. So I'm going to make myself a ham sandwich. And to make myself a ham sandwich, I'm going to use 2 pieces of bread. And I'm going to use 3 pieces of ham. And I'm going to make 1 sandwich, which is, well, we don't usually write the 1, so I'm going to get rid of that. And we're going to make just BR2, HM3, which is my sandwich. The concept of stoichiometry, then, is if I want to make 4 sandwiches, how much bread do I need? If I know I have 18 pieces of ham, I can figure out how many sandwiches I can make with those 18 pieces of ham. And if I am trying to make sandwiches for 21 people, I can figure out how much of each one of my ingredients I need to be able to make those sandwiches that I need to make. And that is stoichiometry. Now, in a fancy definition, basically then, stoichiometry is the number of relationships between the reactants used and the products formed in a chemical reaction. Very much like a recipe because, as I've said before, chemical reactions are exactly like recipes. Except for in a chemical reaction, we usually use 2 cups of this or 3 teaspoons of this, or we can even say 2 pieces of bread. But in chemistry, there's a different unit that we use. We don't use cups and tablespoons and teaspoons. Instead, in chemistry, when I take a look at a balanced equation, the unit we use is moles. So we say that there are going to be 2 moles of bread in this reaction. We say there's going to be 3 moles of ham in this reaction. And we say that we can make 1 mole of sandwich from those 2 pieces of bread and those 3 pieces of ham. So when we talk about stoichiometry, one of the key portions of stoichiometry is that relationship between the coefficients or between the numbers in your balanced equation and each other. So in chemistry, we come up with something that we refer to as a mole ratio. And a mole ratio is basically just a fraction. Oh, I know, bad math word. That compares any 2 parts of a balanced equation. And in a chemical reaction, a mole fraction is key to so many different types of math problems or stoichiometry problems that you're going to be calculating out. So if I take a look at problem number 1 wants to know the mole ratio or the relationship between bread and ham. Well, if I take a look at my balanced equation up here, I know that I have 3 pieces of ham for every 2 pieces of bread. And in that case, then, my mole ratio is written as a fraction. I can say that I have 2 moles of bread for every 3 moles of ham. Or I can write it the opposite direction and it's equally as correct because I can say that there are going to be 3 moles of ham for every 2 moles of bread. And right there is the absolute key to being able to do a stoichiometry problem. It is a relationship between any 2 parts of your balanced equation. So when you get to a stoichiometry problem looks something like this. If you start with 24 moles of bread, how many moles of sandwiches can you make? Now, in any chemistry problem you will ever do, you are going to have a number, and that number is going to be your starting place. So I don't care what type of problem you're going to do, find the number, but 24 isn't enough. Chemistry is based on units. So in this case, it is going to be 24 moles of bread. And just like any other chemistry problem, I can use a fraction. I want to get rid of bread. And if I want to get rid of bread, that's something up with my pen today. That moles of bread needs to go down here. And what am I going to turn it into? Well, in this case, what am I trying to find? And in this case, what am I trying to find? I'm trying to find moles of sandwiches. The mole ratio then gives me that relationship. That mole ratio allows me to switch between bread and moles of sandwich, which we said was Br2HM3. Because according to my balanced equation, I needed 2 pieces of bread or 2 moles of bread to make 1 mole of sandwich. So when I take a look at my mole ratio then, we said that there were going to be 2 pieces of bread for every 1 mole of sandwich, and these numbers basically come from your balanced equation. Now, just like any chemistry problem that we've done before, we want moles of bread to cancel out, and they do, top and bottom cancel, and it leaves me the unit that's on the top, which is going to be moles of sandwich. And mathematically then, this is just multiplying across the top and dividing by anything that's on the bottom. So I'm going to take 24 times 1 and divide it by 2. And so if I have 24 moles of bread or 24 pieces of bread, I can make 12 moles of sandwich. Now, it's very likely that you could have done that problem in your head, and you would have done something very, very similar to that by doing that problem in your head. So let's take a look at another example. If you want to make 12 moles of sandwiches, how many moles of ham do you need? I can use any parts of that balanced equation. So I can take this 12 moles of sandwiches, that's going to be my starting point. And as long as I have moles, I can use that mole ratio from my balanced equation. So I know that whatever this unit is, it's going to go on the bottom. So I can get rid of it because I don't want sandwiches. I want moles of ham. And again, where do I get this number from? This number is going to come from the coefficients in my balanced equation. In this case, I have 3 moles of ham for every 1 mole of sandwich. And so I've got sandwiches on the bottom, so it was a 1 mole of sandwich for every 3 moles of ham. My units moles of sandwich are going to cancel each other out because it's top and bottom. And I want to find the number of moles of ham because that's what my question is asking me about. And so I can multiply across the top, and I can divide on the bottom, and this time it's 12 times 3 divided by 1. So I'm going to come out with 36 moles of ham that I need to make 12 sandwiches. So with stoichiometry, it is about the relationship between different parts of the chemical equation. And when we take a look at stoichiometry, the key part of stoichiometry is going to be the mole ratio. Mole ratio is just that relationship between any two parts to a balanced equation. Your equation has to be balanced. But that is going to allow you to be able to switch between, hey, I've got this much ham. How many sandwiches do I have? Stoichiometry problems will be talked again in part 2 of this video series. Have a great day, guys.